Okay, so here we go again. I still don't have a document camera. I think I'm giving up on my school computer and I'm ordering a special cable to be able to link my doc cam to my laptop, which right now I don't have a cable to do that. And that way we'll be able to do some more in-person teaching. So again, I apologize, you guys, that I'm not able to do this with you live. All right, so let's look at a couple of the library of functions because people had said, yeah, I think a couple videos might be nice. All right, so this first one, f of x equals c. Well, that's just saying it equals a constant. Okay, so if it equals a constant, you could have the domain any real numbers. And the range would be c, whatever c is. So if f of x equals 2, if f of x equals -3, whatever. It's going to be a constant function. So let's do this. Let's get rid of that 2, and let's put a c right there. And gotta have a ruler. So any constant function is just a horizontal line. Okay? So no matter what x equals, the function will always equal c. Now, end behavior. So we did this in Math 3. You should have done it again in math or in pre-calculus. And we will do this again in calculus. We'll have slightly different notation, but the understanding is the same. Okay, so as we head out towards -infinity, we're going to say the function or the y value. Okay, end behavior is just saying, where's the y value of this function headed to? Well, it's not going to go anywhere except for c. Oops, I shouldn't say equals. I should say heads towards c. Okay, as x heads towards positive infinity, f of x heads towards c. So what if this was a 2, we would say the function is heading towards 2. Okay, on both of those. So that's the constant function. Now, this function, the identity function, this is one that I want you to make sure that you always notice, the y equals x function. The y equals x function, it goes on a 45-degree angle, right through 1, 1, 2, 2. It's an important function that you note. And this is it with positive slope. If it had negative slope, it would go this way. So it comes up a lot. So I want you to make sure that you're looking for the identity function, okay? And that's it, right there. So I could put any number I wanted in for x, and I could get any number out for y. So the domain and range are going to be all real numbers. Okay, end behavior. Now there's actually 2 ways that we sometimes think about this. Sometimes we say, okay, well, as x goes to -infinity, y is heading towards x, it's heading towards this function. But we're just going to say it's headed towards -infinity. Okay, the y is going down. Okay, as x heads towards positive infinity. And notice I put the plus sign. Sometimes people don't put the plus sign on that, and it's just assumed positive infinity, just so that you know if you ever see something like that. Okay, the reciprocal function right here, this one is one that I want you to make sure that you understand. And you can just make a little t-chart. And anytime, you guys, that you get stuck on the graph of a function, a t-chart will always help you out. We get really used to going, oh, I recognize this function, and then all of a sudden we get one that we don't recognize, and we're paralyzed. Hello, this is our best friend right here. Okay, so I'm just going to work in the positive quadrant for right now because I know x cannot be 0. So that's telling me something because I can't divide by x. So let's see, if x was 1, well, 1 over 1 is 1. Okay, so it's going to go right there. If x was 2, well, that'd just be 1/2. If x was 3, it'd be 1/3. Okay, so I can see this pattern, that it's going to come down, 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 but it will never, ever equal 0. because it can't. So I could have 100. I could have 1/100th. I could have 1,000,000, 1/1,000,000th. So it'd be infinitesimally small, but it will never ever touch this axis. Remember, we call that an asymptote. Now, what's happening over here? Well, let me put in a half. Well, 1 divided by a half. So 1 divided by a half. Well, that's 1 divided by 1/2, which that's 1 times, I'm sorry for using the time symbol, but just showing you our good old 6th grade fractions. That's just 2. So 1 divided by anything is just its reciprocal. That's a really good little trick for you to know. So at a half, it's at 2. Well, at a third, 1 divided by a third, it would be at 3. 1 divided by a fourth would be 4. So it's going to do the same thing. It's going to get infinitely close right up here, but it will never ever touch that y-axis, the same reason. Okay, so here, it's going to do the same thing on the negative side. Okay, so that is what our reciprocal function looks like. And it has 2 asymptotes in there that we got to watch for. Okay, so let's look at the domain of this. Okay, so the x values, I could put anything in I wanted for x except for 0. So the way I show that is I'm going to go from -infinity to 0 in union with, and it's not really a U, it's a different symbol that looks like a U, to 0 to infinity. And notice that the open parenthesis, or the parenthesis there, is saying it cannot equal 0. Now, the same thing is going to happen on the range, that the y values go from -infinity, I can never have a y value equal 0, to +infinity. So from -infinity, can't equal 0, and then it goes infinitely close to 0, and to infinity again. Okay, so end behavior. Let's see what's happening. As x approaches -infinity, the function, or the y value, is approaching 0. Okay, as x approaches +infinity, the function is approaching, so as I'm going this way, 0. And remember that these are horizontal asymptotes. So this is kind of a thing that I want you to think about, that they're horizontal asymptotes at these 2 spots right here. Because we're going to see that come up in calculus. We're going to see, well, how do we know that there's a horizontal asymptote at any spot in some weird function that we don't know? And if the function is approaching some value, that is a horizontal asymptote. So just as a side note, and I know I've written all over the place, that we have a horizontal asymptote at y equals 0, and we have a vertical asymptote at x equals 0. So these are kind of just 2 nice to know. There's our horizontal asymptote, the equation of the x-axis, remember, is y equals 0. Here's our vertical asymptote, and the equation of the y-axis is x equals 0. Okay, I'm going to stop there.